Welcome to part 2 of film processing. Now, to move away from the chemical aspect of things and really to start to dig into the main systems that make up the processor or allow that processor to mechanically function, there are 6 main systems. All 6 are listed here. So transport, temperature, circulation, replenishment, dryer, and electrical. So must have all of these functioning appropriately for our processors. So these things need to be understood, and that's why we're going to break them down a little bit. When you see the processor with its nice plastic coverings, if you never really worked with one, I don't think you probably get the magnitude of how much really goes into the processor until you really look at this picture, and you can start to see all of the components that make it up. But the transport system is considered to be the largest and most complex system of the film processor. So transport, just like the transportation system or highway system, it's going to move something from one place to another. So highways, cars from one place to another. The transport system within a film processor is going to move the film from one tank to the next tank. So there are 3 individual subsystems associated with this, and we're going to break down all 3 of those. So the roller system is going to be what helps keep that film rolling throughout from tank to tank. So there are entrance rollers, and of course they're found on the entrance rack, so they're going to feed the film into the system. They're typically like a rubberized plastic type of roller. There's transport or planetary rollers as well. They're the most numerous, so you can kind of think of these as being your planetary rollers, transport the film, and typically they're about 1 inch in diameter, so not huge. The largest would be the master or solar rollers, and these are typically made of plexiglass or stainless steel, but they're found at the bottom of the solution tank, and what they do is that they help bend the film, not from tank to tank, but really from the bottom of the tank, and then process it back up through the top. So now this particular graphic, you're going to be able to see these transport rollers here and here, so about 1 inch in diameter, but then you also can see the larger master roller down here at the bottom. So as the film comes down, and there's going to be transport rollers all throughout, but as the film comes down, it's going to be fed in through here, and then this master roller is going to help bring it back up. So what's going to help and assist these rollers is going to be this rack-based system. So there are different types. So the entrance rack does contain the entrance rollers. It also contains guide shoes and a micro switch that is going to allow the replenishment system to take place. And we're going to get into the replenishment system, but it is all based on the amount of film that passes through. So the vertical racks, also called deep racks, these are going to contain all of the transport rollers. So they're going to guide the film essentially into and out of each of the tanks. So they would be, help with this aspect of things. The turnaround racks, these are going to contain the master rollers, transport rollers, and guide shoes to help turn around the tanks at the bottom, or turn around the film at the bottom, rather. But next one is the crossover rack, and it's just what it says. It's crossing over from one tank to another tank. So these racks help to take it from the film from developer to fixer, or from fixer to wash, or from wash to dry, depending on the nature. So now we have rollers and we have these racks that is still continuing to help move that film along. The rollers and racks are one thing. Without a drive system, they're not going to be able to turn, or they're not going to be able to function like we need them to function. So this is the part of the system that really supplies that mechanical energy to actually physically move the film. You can see all of the aspects here, and typically within a 90-second processor, which is most commonly used, it's about 60 inches of film per minute is going to be moved through based on how the system is designed, but it is going to depend on the manufacturer. So temperature, as you learned, is certainly key, and developer temperature must be maintained within plus or minus 0.5 degrees Fahrenheit. So it is very, very important. So this system is going to help regulate those solution temperatures. But there are 2 basic types of temperature regulators: water controlled systems. So these are essentially they're going to use the temperature of the wash water to regulate the solution temperatures. So basically creating that 5-degree difference. But more commonly now is thermostatically controlled. So what's going to happen is that there's going to be some heating coils or heating units actually within these tanks that's going to allow it to be heated to manufacturer specifications. So on your input, essentially cold water is going to be taken in, and that's going to be heated up and maintained at a specific temperature. So nonetheless, certainly important for the quality of your film. So this is an important system. So those heating units that I just mentioned, for those temperature controlled systems, they're found within the bottoms of the tanks. So we know if the bottom the bottom would be warm, the top would be a little bit cooler. So how to get around that is with the circulation system. So the whole idea is that it's going to provide uniform temperatures to be in place. But it's also going to make sure that the chemistry stays agitated and is jiggled, so you don't have different amounts of chemicals up top and different amounts in the bottom, but you want a nice uniform amount throughout. So circulation is important, and you can see that the circulation rates do differ depending if we're talking about the developer or the fixer. So with each passing film, we're going to use a little bit of the developer and a little bit of the fixer up. So we have to maintain a constant useful supply of developer and fixer. And how this is going to be defined is, for developer, is the amount of bromide that's within the developer. So it's ideally between 4 grams per liter and 8 grams per liter. So you can think of the ideal as being 6 grams per liter. But if we're over that, it's going to be indicative of under replenishment of the developer. But if we're actually below 4 grams, so less than 4 grams per liter, it's going to indicate over replenishment. So these are going to affect the appearance of the optical density on the film, so it's not something that we really want to deviate too much from. Fixer, same type of idea, except we're between 4 and 6, and it's not about bromide, but it's about the amount of dissolved silver. So certainly something to look at, and the replenishment system is going to help make sure that our chemistry levels are appropriate for accurate film processing. The replenishment system can be set up in a couple different variations, one of which is called volume replenishment, and this is just a system that for each film that passes through, there's going to be a specific amount of developer and fixer that's going to be added through. So with the developer, for basically for a 14 by 17 inch film, it's going to use about 60 to 70 milliliters. If you're talking about the fixer, for the same piece of film, it's going to use 100 to 110 milliliters of fixer. So much more fixer is always going to be used than developer, so in comparison. So if you want the specifics, developer is 4 to 5 milliliters per inch is going to be used, and for fixer it's 6 to 8 milliliters per inch. So not quite double, but you're pushing near double. So if you're ever wondering, hey, I'm using so much more fixer than developer, why? It's just how the systems are set up to utilize more fixer. So if you're purchasing these things, you'll have to have more fixer on hand. Flood replenishment is another type, and typically this system is used for processors that are not in constant use. So smaller volumes, so less than 50 14 by 17s processed a day, but these are typically controlled by a timer though nonetheless. So a little bit different. Volume replenishment is much more common type. Now the final system is the dryer system. So after the wash, it enters the dryer, but the dryer itself takes a ton of power. Anywhere between 60 to 80% of all power dedicated to the processor is going towards the dryer, and power is indicated in the unit of watts. So you can see 1500 to 2500 watts is going to be utilized for this system. But what happens is that you have all of these over here, these hot air tubes, and these hot air tubes are forcing air against the film. So it was previously wet, and it wasn't a cold wet. The developer temperature is warm, but now you're having all of this very warm air, about 140 degrees Fahrenheit, being thrown towards the film. But the film is also moving through at a very high velocity, and then upon exit, it should be dry enough for archival quality. So in order for all of those systems to work that I previously mentioned, we have to have electrical energy being supplied to the processor. So the final component would be the electrical system. So that needs to function in order for the other five systems to function as well. Now, even though all systems are going to have that developer, the fixer, and the wash and the dry, all systems are not created equally, and these systems are all named based on how long they take to process the image completely. Most commonly, you're going to see the 90-second processor being used, so from start to finish. But nonetheless, the first origin of the automatic processor happened in the 50s, so it does about 100 films per hour, so still could potentially be used. You never know where in the world some of these processes are being used currently, and just because they're not used in our country doesn't mean they're not used in another country. So next up, 3-minute processor can do about 200 films per hour. Also maybe called a double capacity processor because it's faster, but it's twice as fast, but it can do twice as many, so twice the capacity. A 90-second processor can handle about 300 films per hour. First was developed around the mid-60s. Like I said, it's still the most common type out there right now. But then we continue to get faster and faster, so a 60-second could do about 350 films per hour. And a 45-second is considered the newest type, but it does require special films and special chemicals as well. There can be a multi-speed system, and this can be established based on a variety of film combinations, but also a variety of intervals, so maybe it can be dependent on the temperature at that time, how long it's going to keep it in the developer, so it could have more variation, but definitely a sophisticated system. But nonetheless, 90-second processor is the one to know, as it is the most common type still. Continuing on with the idea that not all processes are created equal, is that they do vary in size. So keep in mind that they're all still going to have all of those subsystems, but the size of them and what they can actually handle may vary. So what is considered to be the floor size is here, this big old monster, largest size used for the high volume processing conditions, normally found in a hospital, sits directly on a floor. Next size here is the intermediate size, so it's kind of in between the two sizes. So used in smaller clinics, physicians' offices, maybe you would see it in an outpatient facility. I actually saw one of these, actually more than one of these, utilized in a radiation therapy facility, so to process port films. So it can still be used, and it is still used today, at least in a backup capacity. Final aspect of things, and I think is what's becoming more common because darkrooms are going more and more away, is going to be a table or the countertop size of things. So it sits on the table, and it's just used for lower volume. So it still has the ability to function appropriately. It's still going to go through all of the individual tanks, but much smaller, so it's going to be used for a much smaller volume of things. Now, the final points that I want to touch on is the different variations of setups for these automatic processors, whether they're in a darkroom or even outside of the darkroom. The first one to touch on is the totally inside the darkroom. So this is considered to be the least desirable of options, largely because it's going to be so dependent on the humidity and heat of the darkroom. It's all going to be contained within one particular area. But a major benefit of it is that if your film does get jammed, you can potentially still save that film because it's going to be still under the safe light conditions, so it's not going to be exposed to that daylight, where some of these other ones are going to be exposed to some daylight here. Bulk inside darkroom may be considered the best, so you're not going to be as dependent on the humidity levels and maintaining those conditions. But it's still, for the most part, if you have a jam up, you may be able to still save your image. Bulk outside, you can utilize this for a variety of reasons, but what may happen though if you get a jam up is that, hey, there's very little options to actually save that film, so that may not be to the benefit, but in terms of, elimination of heat and noise and humidity, certainly is a good benefit there. So, you kind of have your risk versus reward, but there is new systems out, total outside systems, or what's more commonly referred to as a daylight system. They do not use a darkroom at all. So, it just depends on the kind of film that you have, the setup of your department, what's already maybe in place, or what you're really transitioning to. So, just kind of keep those in mind, that there are different variations of setting up the automatic processor in addition to different sizes and different capacities. As always, thanks for watching.